rating. So first we will look at large signal class A amplifier. So we will start from class A large signal amplifier. It is a common emitter amplifier. It is a very simple connection. So in the collector side you have RL and VCC. Emitter is grounded, so it is a common emitter amplifier. And at the base side you have a resistance RB and VBB. This VBB is given at the base side to ensure that the transistor is conducting for the 100% of the time. So this VBB ensures that the VBE value present here is always more than zero point 0.7. So the transistor is on for the entire duration of the time. So this VBB is present across the emitter and base junction, right? So it ensures that the VBE or the cut-in voltage of the transistor is always 0.7, so that it is on for 360 degrees of the input cycle or 100% of the time. Okay, this BBB and VCC are the biasing voltages which will fix the Q point exactly in the middle of the load line, so that the transistor is going to be working in the active region. Apart from these two DC voltages, you have an AC voltage Vs, which you give the input signal for amplification, and you take the output from collector. From RL, we take the V0. We take the output voltage from the collector. Okay, so this is the very simple diagram for class A large signal amplifier. See, class A amplifier is a conventional CE amplifier, so there is nothing different in the circuit diagram. It is going to be a conventional common emitter amplifier, and I'm going to keep my biasing also very, very simple. So I'm going to have RL and RB as my bias resistors. VCC and VBB will fix the Q point at the center, and any signal provided to the base of the transistor will be amplified perfectly and present at the collector side of your transistor. Okay, so this is a simple transistor amplifier that supplies power to the pure resistance load RL in the as shown in the figure. So we are assuming that the Q point is exactly in the center. So if the Q point is exactly in the center, if the input signal is a proper sine wave, we can predict what is the output signal from the output characteristics. So you can see the diagram here. This is the output characteristics, right? So for different values of base current, you are drawing the different values of collector current. And when you draw the load line will be somewhere going like this. So the midpoint will be your Q. So in the midpoint of the DC load line will be your quiescent point. So draw a line from the Q point on both sides of the graph. So that is going to be your reference point. So above and below the Q point, you will have your sine wave varying. So you see this sine, the base, the axis of the sine wave is going to be your Q point in the input and output side. And above the axis, you will have positive half cycle and negative half cycle of the input. This is going to be the input. And here you can see the output, which is amplified version of input. And you see input starting at 0, but here first you have positive half cycle followed by negative half cycle. But here you have negative half cycle followed by positive half cycle. Because common emitter amplifier introduces a phase shift of 180 degrees between the input and the output signals. Okay, so we draw the Q point everything from the output characteristics graph. So take the output characteristics graph, draw the DC load line. Once you fix the Q point at the center of the load line, draw the reference line for the input and output. Above this reference line only, the waveform should vary. So at the maximum of the sine wave and the minimum of sine wave, extend the lines and draw it from the load line. You can see the variation of the signal at the output. And the output will have a phase shift of 180 degrees, which is the characteristics of your common emitter amplifier. So remember, all amplifiers are designed based on the output characteristics graph only. So that is what is shown here. This we are drawing from this graph only. We are drawing the input and output waveforms. Okay, so that is what is shown here. The Q point is exactly at the center, so you can draw the diagram for IC, VC. IC is going to be the collector current and VC is going to be the collector